We're live. This is Math 60 Intermediate Algebra, and we're going to be graphing circles now. If you've been watching the whole playlist, we just finished parabolas. As we move into circles, the way that I'm going to talk about circles is to compare and contrast and remind you about what parabolas looked like so that we can kind of springboard off of parabolas to get to circles. So the first thing to notice about circles is, there are a couple things you'll notice right off the bat. First is, in our first version, this is the standard form, x squared and y squared, x and y are both squared. Do you notice that? They both have squares attached. And they're both on the same side. So how is it different from a parabola? Parabola, in its standard form, x and y on opposite sides. And only one is squared. Oh, great. I know how to write that. It looks like only one is squared. I don't know what that word is, but you can hear me say only one is squared. A circle, x and y, oops, I should write and, so not x plus y, on the same side, both are squared. Okay, so those are the big difference. Parabola, they're on opposite sides, one is squared. In a circle, x and y are on the same side and both are squared. Okay, and so let's talk about the two kinds of circles. There are the easy circles. This circle is centered around the origin. So it's going to be a circle that looks like that, where that's x and y, which is really lovely. X squared plus y squared equals r squared. There's a center at 0, 0. The radius is r. So r is the distance from the center out to the outside edge. The diameter is 2r. That makes sense. There's an r here and an r there. And here's the intercepts. Woohoo! Life is so good when it's centered at the origin. Then there are the less friendly circles. These less friendly circles are centered. Now notice we're still using the h and k, but now h and k are both inside with us. And in standard form, our center is going to be at h and k. Our radius is r. Our diameter is at 2r, just like normal. The problem is if we just have a circle centered at, a random point, the intercepts are not going to be easy, beautiful intercepts like they were up here. They're going to be whatever points the circle happens to intersect, which could be any, there could be, it could be so far over to the side that it doesn't even have any intercepts. This is the kind of bizarre world we've stepped into now. Because circles don't have arms that go off forever, you can have a circle that has no intercepts. So finding the intercepts, you plug in x equals 0 and y equals 0, and you hope for the best. The way you graph it is you should find the center first. So put it in standard form and then plot the radius up, down, left, and right. And I will show you how to do that. Shall we get started? So we're going to get started with a very friendly circle. This is not quite the friendliest circle is known as the unit circle, and I'm not graphing that here. That would be x squared plus y squared equals 1. I'm going to go a little bit harder than that. We're going to do x squared plus y squared equals 9, which will give us some good meat. It'll give us something good to graph. So first thing to notice is that x squared and y squared are just perfectly happy. There's nothing else on that side, which is fine. On the right-hand side, I'm going to take that 9 and I'm going to write it as 3 squared. This tells me the center is at 0, 0. This tells me that the radius is 3. So the one thing that gets confusing is it looks like the radius here is 9. It's not. The radius is 3. Remember, this is r squared. So in our formula, the general format is x squared plus y squared equals r squared, which might remind you of the Pythagorean theorem. There's a good reason for that. This stuff is all interrelated in a beautiful way. Once you take trigonometry, the whole world just explodes with, oh my gosh, where we've been going around in circles, literally. Okay, so literally that's all you have to do. Seriously, the friendly circles are so friendly. They're my favorite things to graph. Easier even than a line, because you don't need a rule. Okay, you do need a ruler for this. You have to see how I'm using a ruler. Again, don't put those ruler factories out of business. Then there'd be chaos. No one would be able to measure anything. I got my X, I got my Y, because we haven't forgotten all of our manners. Now, my center, again, was at 0, 0. You can mark it, but it's not technically part of the graph. So you don't want to put a big point there because it's not actually part of the graph. It's just where the graph kind of opens up. It's the belly button of the graph. The radius is 3. So what I do is I start at the center and I go up 3. 1, 2, 3. And that point is 0, 3. And I mark it. And then I'm going to go out 1, 2, 3. Now I went to the left, so this is -3, 0. Put a point there. Then 1, 2, 3. This point is 0. What? You got it. -3. And this point, 1, 2, 3. There's another point there. That's at 3, 0. Okay. That's it. Those are your intercepts. I know. This is just like it. This is like eating a cupcake on the beach with a nice breeze in the shade. Oh, on a beautiful day. Now, in a perfect world, I would have something called a compass. That thing that has it's got basically like 2 parts like this. One is probably a stabby metal piece that you've stabbed someone with, in middle school, and the other side has a pencil, and you would hold one in the center, and then you would roll it. You guys can't see that. You would roll it around. For our purposes, I'm just going to sketch. That's it. X squared plus y squared equals 9. Life is good. Life is beautiful. Shall we try one more? I think I'm feeling dangerous. Let's try one more. Okay. So then the next one I want to try, a little less friendly. But don't panic. No panicking. No panicking. Life is still beautiful. We're not going to have to complete any squares. Not that I'm saying we would, but maybe we do on the next one. So the first thing we want to do is I'm going to remind myself, okay, we're not actually looking at 9. We're looking at 3 squared. Remember that. So we're looking at 3 squared. So my radius equals 3. Now my center, I don't know why I want to call it a centaur. And if I could draw a picture of a centaur, I would totally do that right now. I'm not sure why, but let's just go with it. Here I've got Godzilla instead, kind of like a centaur. Imaginary creatures. Okay, the center. Now, in the formula, let me get that page back so we can study the formula again. Notice that in the formula, there's supposed to be a minus. It's x minus h and y minus k. So right here, I should have x minus h. So h is 1. But here where I have y minus 2, that's actually y minus a -2. So the center is actually at y equals -2. Does that make sense? It's the opposite of whatever appears inside. If it's on the outside, it's the same. If it's on the inside, it's the opposite. Okay, so I've got a center at 1, -2. It's not impossible, and a radius of 3. So I should be a little bit mindful. Since I'm centering it, I'm going to write this again down here. Give myself lots of room in case we decide to doodle or something. Let me write that there. Let's come here. So the thing is if I'm going to start over at 1, -2, and my radius is 3, I'm going to go down pretty far. So I might want to put the x-axis kind of up high. like that. If you have a large piece of graph paper, then it's not going to matter. Here's y. Okay. So I'm going to find the center. It's at 1, -2. And I'm going to make a little light dot because remember, this isn't actually on the graph, but that's the center. Now, this is what I'm going to do. I'm going to take the radius, exactly what I did before. I'm going to start at the center and I'm going to go 1, 2, 3, and draw a point. I'm going to figure out what that point is. That point is going to be, let's see, 1, and that looks like 1, 1, 1. So we've got the point 1, 1. I'm going to take this point and I'm going to go off to the left. 1, 2, 3. Oh, let's see. This is -2 in the x direction, -2 in the y direction. That's cool. That's also another double. Okay, start the center, the belly button, and go down 1, 2, 3. So this is going to be x is 1, y is 1, 2, 3, 4, 5, -5. And then I'm going to count out 1, 2, 3. And so this is going to be, let's see, 1, 2, 3, 4. This is 4, -2. Notice that these 2 points, the points that are across the circle, diametrically, that's where the word diametrically opposed comes from, opposed on the diameter. So diametrically opposed here, they will have the matching x's, and these 2 have the matching y's. And then I'm going to play connect the dots. Okay, I'm not the best at this game of connect the dots, but and again, if you want to use a compass, go ahead. That would be great. Now, the bad news. I've got some intercepts. There's an intercept here. There's an intercept here. There's an intercept here. Oops, sorry. There's an intercept here. So I've got 1, 2, 3, 4 intercepts. So the intercepts are what I'm going to use all the space for. So you ready? Let's do it. It's a graph, though. I mean, and a lot of teachers would be like, there's my graph. And, the intercepts and whatever. Wave your arms around a lot so no one can tell that you didn't put in the intercepts. And maybe you get full credit. But not with this teacher. So let's talk about the intercepts. Intercepts are something that circles do terribly. They really do. They're just not fun to do. So pick one x or y to start with 0 and plug it in. So here I get 1 plus y squared plus 4y plus 4 equals 9. I am going to move everything over onto the left. So I get y squared plus 4y plus 5 equals 9. Y squared plus 4y minus 4 equals 0. And then I try to think of, can I think of anything that will factor? And I'm not sure I'm thinking of anything that will factor. So I'm actually going to have to use the space. Y squared plus 4y minus 4 equals 0. So y equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. The opposite of 4 plus or minus 4 squared minus 4 times 1 times -4 all over 2. -4 plus or minus 16 plus 16 all over 2. And I need another piece of paper. To continued. Y equals -4 plus or minus radical 32 all over 2. So far, so good? Okay, so radical 32 is 2 times 2 times 2 times 2 times 2. I need a bear. Here's my square bear. Rawr. So these 2 2's go running. Yum, 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 yum. These 2 2 goes running. Yum, 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 yum. I get 4 radical 2. So the square root of 32 is 4 radical 2. So up top, I've got -4 plus or minus 4 radical 2 all over 2. Now, I could factor out a 4. I only need to cancel the 2. So I'm going to factor out a 2, which I know a lot of people are like, wait, you have to factor the whole thing. And the answer is no, you don't ever. The great thing about math is you don't ever have to follow anyone's rules. You do whatever you want to do. As long as you're not violating logic, as long as you keep the balance, you preserve the value, you can do whatever you want. You want to multiply by 17 over 17 right now? You do it. You do that and you be happy with your 17s. And just know that when I'm king, 17 will be gone. But, for now, enjoy it. Cancel the 2's. And I get -2 plus or minus 2 radical 2, which is -2 plus 2 radical 2, and -2 minus 2 radical 2. Okay, so what are these? These are the points when x is 0. Okay, so let's go back to our graph. This is when x is 0. This one's bigger, this one's smaller. So this right here is 0, comma, -2 plus 2 radical 2. And this one right here is 0, -2 minus 2 radical 2. So we just identify what the intercepts are, but we don't necessarily graph them. What you might want to do is quickly calculate. Where's my calculator? What you might want to do is quickly calculate an estimate for them to make sure you're not completely off. Let's see, -2 plus 2 times radical 2. So this is about 0.8. So if you see here how this circle, even hand drawn, kind of came just below the 1. Okay, so about 0.8. Yeah, that seems right. On this one, -2 minus 2 times square root of 2. This one is about -4.8. 1, 2, 3, 4, 5. So it's right above. So yeah, I didn't graph it exactly perfectly, but it's in the right ballpark. So let's dance and sing. I'm about to sing the Fraggle Rock song. I'm gonna try not to. Okay. So you're like, okay, so we're done now. It's like, well, we're done with x equals 0. Now we try y equals 0. Hey! I know. Math is kind of never ending. That's why we have computers. Computers will do this so much faster for us. Okay. So I'm going to show you an alternate way to do this. I probably should have shown you on the first one. You ready for the alternate way? This would have been a lot faster, I'm realizing. Oh, well, I showed you one thing. I'm showing you another. What if we don't multiply this out? What if you're like, no, I refuse. I don't accept this. And I'm like, fine, that's okay. Subtract 4 from both sides. Fine. X minus 1 squared equals what, 5? Okay, let's square root both sides. And you're all saying, wait, we could do that? And I'm like, yeah, totally. Again, as long as you're not violating any of the rules of logic, the basic rules of balance, you do whatever you want. I know math teachers all seem so boring and OCD, and in fact, we're big rebels. We're anarchists. We're the ones in class who are like, we don't want to do it that way. We're doing it our own way because your way is stupid. Sometimes the stupid way is the right way, but and at this point, you're like, seriously, why did you show us the other way? I was showing you the other way just to show you the other way. Does this make sense? This is another approach. It's actually much faster. I'm wishing I did this instead of all of that, but both ways work. And if this way doesn't make sense, you can always go to the other way. So this is going to be the 2 points, 1 plus radical 5, comma 0. or 1 minus radical 5, comma 0. Now, which one's going to be bigger? This one's going to be bigger, right? So if we look at our graph, I've got two intercepts right there. I've got this one, which is to the right, it's bigger. So this one is going to be the point 1 plus radical 5, comma 0. And this point, I'm running out of, see, circles are kind of bonkers to try to write them all in. 1 minus radical 5, comma 0. Okay. Ooh, you know what that kind of looks like? Doesn't it kind of look like a coronavirus? Ooh. Okay, so our coronavirus circle here is done. We graphed it. I mean, you might want to put in a label. I'm always forgetful about writing in the labels. Again, anarchists don't have labels. We want a label-free society. Okay, that's it. Number 2 is done. And next up, we will graph something horrible. You ready? Woohoo, I'm excited. I hope you're excited.